What's up, people? Hello, everyone. How you guys doing? Welcome to Vedantu 9th and 10th English channel. How is everyone feeling today? All awesome? How's everyone? Hi, FNG. What's up? How was your day? What is new in life? How is everything going? How are your preparations going? How nervous? What is your rate of nervousness at this point of time? Since your sample papers have come out, what is it like? How many of you guys went through the sample papers, by the way? How many of you guys went through the sample papers? Hi Devadarshini, what's up? Hi Haksha, what's up, buddy? How you doing? Welcome. Hi Jenny, what's up? I'm great. How are you guys doing? I mean, I have slight fever, but otherwise I am awesome. How are you guys doing? Hi Ayushi, what's up? Welcome. Hi Rishi, hi Jenny. Yeah, this would be relevant for ICSE also, because these topics you ICSE students also have. So it's going to be helpful for both ICSE as well as CBSE. Don't worry. Yeah, it's harder than I thought. Huh? There are a few mistakes though, but otherwise, it doesn't seem that hard per se, but still something that you should work towards, so you know what are your weak points. Work on that, right? So anyways, very warm welcome, people. My name is Anoop and this is 9th and 10th English channel of Vedantu. So what we are going to do in today's session is basically we're going to talk about something called as the force on a current carrying conductor, also known as the Lorentz force. So we're going to understand about that, because understanding this concept is the base or the foundation that's going to help you to understand the working of motor. So this topic that I'm going to teach you today is going to be super important. So pay attention, sit back, relax, chillax, and listen, stay till the end. I participate in every single quiz question and make sure you give your very best. Right? So before we get started, guys, let me tell you one thing, that you guys can take the quiz after the session is done as well. So you'll be getting a link in the description. You can take the quiz after the session is done. So this is the link for that. Click the link to attempt the quiz. So you can click on that link and take the quiz once again after the session is done. And if you're on a mobile version right now, if you're basically watching the session on your phone, then you'll have to basically click on this drop box to view the description, and then again click on the link to attempt the quiz after the session is done, right? So with that said, people, let's quickly go to our first couple of quiz questions, because we always do this. So let's start with the quiz questions, do a couple of questions from the previous session. That was the second session of magnetic effect of electric current. I hope you guys were there. If you haven't participated or if you haven't seen the session yet, I would urge you to watch the session after this particular session is done. Go through that as well, so that you get an idea of what was taught in the previous session, right? All right, so you have to do this, people. Go to a new a new browser, open up a new tab, and go to www.joinmyquiz.com. all right, joinmyquiz.com, and once you enter this website, you can enter this code 554793. all right, let's go. Hi Chennai Express, what's up? No, it's not Menti anymore, but we'll have quizzes, that is for sure. Thank you. And alright, kaise ho people? All good? I'm good, Muskan. How are you? Hey, this is the link, Yobu. You have to go to joinmyquiz.com and enter the code. The code is 554793. I hope you can see this code. I've highlighted this over here. So this is the code and this is the link, joinmyquiz.com. It's not Menti anymore, but we'll be anyways taking quiz over here, right? 4 of you guys are here, but everyone else is still waiting for Rahu Kala, I believe, right? Waiting for the right time. You're waiting for the time to hit 3:05 so that you can start the quiz. I would urge you not to do it, because it's still not going to help you to come to the top if that is your intention. As long as you don't put in your 100%, all these extra beliefs is not going to help you. I'm telling you that. All right, so join immediately, join quickly. Hi San, what's up? I'm good. Fun with DP. How are you? Mamta ji, what's up? How are you doing? Yo, quickly. AKR sir is doing good. AKR sir is doing much better now. Don't worry. He'll be back pretty soon. So don't worry. Look out for that. All right. He'll be back with a bang. We'll be back with a awesome news. It's gonna come back with a super awesome news. That news is gonna blow your mind away. I'm telling you that much. That news that he's gonna tell you guys in a couple of days, no, it's gonna blow your mind away. I'll tell you that much. I'm not telling you what this thing is. It's his secret to tell, but I'll tell you that much. That I promise you, it's not gonna let you down. That much I'll tell you. All right. Sure, don't worry. I've uploaded all the notes from my end. The team has to upload it. All right. So quickly, guys, quickly join the quiz. Once again, you have to go to joinmyquiz.com and enter the game code. The code is 554793. All right. So I hope majority of you guys are here. I'm going to start the quiz right now. You guys can join in the quiz in between also. There's no hard bend rule that if you don't join in the start, you can't do it later. So make sure you join the quiz and don't just sit there, right? Because both for the questions right now that we're going to do is basically the questions from the previous session. And after this, after the topic is done, we'll come back to this Mentimeter again, or this quiz time. And again, we're going to do quizzes from what we have learned in that next couple of minutes that we're going to learn in the session, right? All right, people, I'm going to start the quiz right now. Here is your first question out of 8 questions. This is your first one. Let's go. 3 seconds. Inside the magnet, the field moves from south to north, north to south, away from South Pole or away from North Pole. Inside the magnet, how does the magnetic field lines move inside the magnet? Very simple question. If you have attended the previous session, this is something that you will easily be able to answer without even thinking much. But go ahead, people. 10 more seconds. I need to reduce the sound though. It's very loud. 7 more seconds. Absolutely. Don't worry, guys. I've already uploaded the PDF from my end, but the team has to upload it. So I'll talk to the team and get it done. Don't worry. All right. Anyways, here is your first leaderboard. So, what's up, buddy? 1,000 points. Then it's Minnal Murli. Arre. Big fan, Minnal Murli ji. Then you have Zed Samosa. Big fan samosa. I love samosa. Then is Jenny, KV, Yobu. Then we have Nive. How is AKR? AKR sir is good. I hope Nive is now, but yeah, he's doing much better now. Devdarshini, Jay, Deepu, and everyone else still at 0. Still haven't opened up their account. It's all right. 11 of you guys managed to give the right answer. Congratulations, people. So outside the magnet, the magnetic field lines are moving from north to south, and inside the magnetic field lines are going from south to north. That's how it's forming a concentric circle. It's basically forming a complete loop, right? So that would be the answer for the very first question. It's all right. First question. So take a chill pill. We have a lot of questions to go through. Second question. More power. Fighting. Let's go. Second question. The front face of a circular loop of a wire is north pole. All right. The front face, the side that you are facing, you have a circular loop in front of you, and the side that you are facing is apparently the north pole. What would be the direction of current in that particular face? If you are facing a certain circular loop and that face is apparently the north pole, what can you tell about the direction of the current? Is it clockwise, anti-clockwise, towards north, or towards south? Super easy question again. Something that you've already studied in the previous session. Let's see how many of you guys can figure it out. Anyways, here is your leaderboards. We have Soham still on the top, followed by KV on the second. What a jump, KV. Then it's Zen, Minnal Murli, followed by AKR. Then it's Devdarshini, Jay, Harsh, Sahu, ma'am, love you. I'm telling you, this quiz is being misused for so many Valentine's Day, proposals and all these days. I don't know how to stop it also anymore. Harshad, Samosa, Jayadi, Yobu, Dipanshu, Deepu, all is well. Ayushi, Aditya, Narendran, big fan of you. Thanks a lot, buddy. And everyone else in still 0. It's all right. Nonetheless, 15 of you guys got the right answer. That is not a bad number. Better than the previous one. Previous one was 11. Now it's 15. So good jump. Not bad. Moving on to the third question, people. The third question. Here we go. 3 seconds. The question says, the magnetic field inside a long straight solenoid carrying current. All right, you have a solenoid which is carrying some current, a straight solenoid carrying current. What does the magnetic field look like? Is it going to be 0? Is it going to decrease as we move towards the end? Is it going to be same at all points, or is it going to increase as we move towards the end? Now they're talking about the magnetic field inside the solenoid. Inside the solenoid, what does the magnetic field look like is the question. Very simple question again. Let's see how many of you guys can get this one right. Let's go. How to enter, guys? You have to go to joinmyquiz.com. You have to go to this website. Oh my god, did I just click on it? Yeah, you have to go to joinmyquiz.com and enter the code 554793. All right, that's the code. So go to, you can see this, no, go to joinmyquiz.com/pro and enter this code 554793. Whoever is asking for the code, this is the code. You can join the quiz and take part in the rest of the questions. All right, people, beautiful. Here we go. And 12 of you guys, a little drop, but that's still all right. Absolutely, guys. It's going to be same at all points, because here's the thing. When you have, okay, let me just present the whole thing first. How do I present? Wait, what? How do I make it full screen there? Wait. Oh, I just refreshed it. Oh, genius. Computer genius Anoop. Wait, one sec. Okay, wait. How do you make it full screen? Wait. F4? Is it F4? Is it F5? No. F5? Oh, no. How do you, F11? Was it? Okay, thank you guys. Thank you. Oh, thank you. I'm a computer genie. Anyway, you can see that, no? I'm a computer genie. So anyways, 12 of you guys got the right answer. Absolutely, guys, because inside the solenoid, when you were to, like, if you try to draw it out, okay, yes, if you try to draw it out, okay, what is this new feature and all? All right, why do they keep changing stuff now? First of all, it's so hard to learn all this, and on top of it, they keep making things even more harder. All right, so if you have a solenoid, guys, imagine there's a solenoid, right? So you have a solenoid. So the thing is that inside the solenoid, you have magnetic field lines, which are basically moving from south to north, just like how it happens in a bar magnet. Here also it's moving from south to north. So it's going to be uniform inside. Outside you will see that there'll be some space in between and all, like basically wherever it's weaker, that means there'll be a lot of space in between, and if it's stronger, it'll be much more closer to each other. So inside the magnetic field lines, it's going to be very consistent. It is going to be uniform. Outside, it's going to be a little bit more, it's going to be like a bar magnet. And you guys know what a magnetic field lines look like in a bar magnet, no? So it's going to be very similar to that. Right. Moving on to the fourth question, people. I believe this is the fourth. Okay, wait. Is this? Okay, no. So yeah, people, that's the end of the first quiz time. I'm really sorry, but unfortunately, yeah, that was the last quiz time. Because the next question is apparently from the topic that we're supposed to study today. Wait. Why you do this? All right. Wait, we've already done the quiz, no? Why is this doing it? Anyway, so people, this is what the leaderboard looks like at this point of time. We have KV on the top, followed by Devadarshini, there's Zen, then it's AKR, Soham, Dipanshu, Minal Murli, Jaini, Big Fan, and all is well, and Narendra. Thank you, people. Thank you. So we're going to come back to the quiz later. I'm still trying to figure this quizzes out. So it's going to be, it's a roller coaster for me as well. So anyways, so people, we are done with 3 questions right now. We're going to get back into the topic. Hardly 15-20 minutes, not more than that. This topic is very important because you need to understand this topic in order to understand the working of DC motor. So this is going to be the foundation, the basic that you need to know in order to understand DC motor. And DC motor is a very important question. Time and again, this is a question that has been repeated. So there's a high probability of that appearing in your board exam, in your term 2 examination. So pay attention to what I'm about to say, right? We'll study for 15-20 minutes and then again we'll come back to the quiz. Don't leave that quiz, leave that tab as it is, but switch back to YouTube right now. All right. Okay. So here's the thing, guys. What I'm going to do is, everyone listen up carefully. 100% attention. All right. Pay attention. Okay. There's a background music. One second, guys. Let me just, yes, done. Thank you. All right. Okay. So what I'm going to do is I'm going to put up a very simple setup. Setup goes like this. I have a permanent horseshoe magnet with a north and a south pole, which is basically hanging. You can see that over here. No, it's basically hanging. This is the north pole, this is south pole, and it's basically hanging. And what I've done is I've basically connected, I've taken a conductor. It can be copper. I'll take a copper wire, a simple copper wire, and I've kept this copper wire in between this magnet All right, in between this horseshoe magnet, what I've done is I've taken a copper wire and kept it between this horseshoe magnet. Now it can be copper, it can be iron, any conductor would do, but I'm taking copper because that is a very common material that we use for conducting and all right, to show experiments in conduction and all that. So you see this one end of this conductor is connected to the negative terminal. You can see the flow of current over here. This is the switch that you see over here, which is given by K, and another end is connected to the positive terminal. So you basically have wound it up over here just to give that support so that it doesn't fall off, right? So you have connected that to the positive terminal. So you can clearly see that the direction of current is this way. Current is flowing from the positive terminal to the negative terminal. So through the conductor also the current is flowing and then back into the cell. Simple. Yes, this is a very simple setup. Now, what this Lorentz force is all about is nothing but this, guys. We know that when current is flowing through this conductor, now this horseshoe magnet has its own magnetic field. This horseshoe magnet will have its own magnetic field, which will be going from north to south. We already know that it will be going from north to south. It will have its own magnetic field. Now, we've also studied in the previous session that if I have a straight current carrying conductor and current is flowing through that conductor, what will happen? That conductor will also have its own magnetic field, and that magnetic field will basically look like concentric circles. We have studied this in the previous session. So we talked about the right hand thumb rule. You guys remember that, right? The right hand thumb rule. So basically, if I want to find out the direction of the magnetic field, all I have to do is imagine this is the conductor now. So current is flowing from left to right, so right to left. So if I hold my thumb such a way that if I grip this conductor, the thumb shows the direction of the current and the enveloping fingers shows the direction of the magnetic field. And that is what is seen over here as these concentric circles. So this conductor also has a magnetic field, and this permanent magnet obviously has its own magnetic field as well. Now here's the thing, guys. We know that the current flow is nothing but flow of electrons. Right, mostly it's nothing but electrons, right? Electrons moving from one end to another, that is what is called as current. Rate of flow of these electrons or rate of flow of charge is what is known as current. Now here also the electrons are flowing through the conductor. From one end to the other, the electrons are flowing. Now here's what happens, guys. When these electrons are flowing through the conductor, what happens is that because of the external magnetic field, that is because of this horseshoe magnet, this electron, this charge will experience some sort of force. The charge that is there, the electrons that are flowing. So in this case, the electrons are basically flowing in this direction. Electrons are flowing in this direction because current is in the opposite direction. So you see this, electrons are flowing from left to right. So as these electrons are flowing through this conductor, because of the permanent magnet, because of the horseshoe magnet that is there, because this conductor is placed between that horseshoe magnet, right? And this horseshoe magnet has its own magnetic field. So that magnetic field, that external magnetic field, will exert a force on this charge which is in motion. This force can either repel the conductor or it can attract the conductor. Now, how do you decide in which direction it's going to go? I'll tell that in a minute. But yes, this is the basic funda behind it. So once again, people listen carefully. So imagine I have a horseshoe magnet. This is my horseshoe magnet, right? And this horseshoe magnet has its own magnetic field. I have a conductor that is placed in between. This conductor, let's say that current is flowing in this direction. Which means that my electrons are flowing in the opposite direction, which is nothing but the charge, right? So as these electrons are flowing, because of the magnet, that charge, that electron will experience a force. That force is what is known as Lorentz force. Understood, people? That is all. There's nothing else to it. This is the basic funda. This is the basic concept behind it. So if you can find out the direction of force, and if you want to find out the direction of force, that is where Fleming's left hand rule comes into the picture. So it's basic science. There's nothing too complicated about it. It's very, very simple. When electrons are flowing, it experiences a force because of the magnetic field, because of the external magnetic field. That is what is known as Lorentz force. That's it, nothing else. Now, if I want to find out the direction of that force, this is where Fleming's left hand rule comes into the picture. What is Fleming's left hand rule? All you have to do is this. Take your left hand. All right, don't take your right hand. Take your left hand. Point your thumb, your index finger and middle finger such a way that they are all perpendicular to each other. Perpendicular in the sense 90 degrees over here, 90 degrees over here, and 90 degrees over here as well. They are all perpendicular to each other. 90 degrees, 90 degrees, and 90 degrees again. So they're all perpendicular to each other. What I have to do is very simple. If I extend my fingers such a way that they're all, my index finger, my thumb, and my middle finger, such a way that they're all perpendicular to each other, my thumb shows the direction of the force on the conductor. My thumb shows the direction of the force on the conductor. My index finger shows the direction of the magnetic field, and my middle finger shows the direction of current. The most easiest acronym to remember this is nothing but father, mother, child. Father, mother, child. This is how I remember it. So father, mother, child. So basically, father, which is nothing but F, is nothing but the force. The force, the direction of force on that conductor, in which way the conductor is going to swing, whether it's going to go towards the magnet or away from the horseshoe magnet. That direction is decided by the thumb. That the thumb shows the direction of that. The mother, which is nothing but the M, is nothing but the magnetic field. M is nothing but the magnetic field. So it shows the direction of the magnetic field, which is generally from north to south. And C, which is nothing but the current. Current, you using your middle finger, you can find out the direction of the current. So to give you an example, look at this one. So there's a simple, simple setup. I have two bar magnets. You can see that north pole and there's a south pole over here, and there is a current carrying conductor placed in between. So if you look at it, the current is going from left to right. That is shown by my middle finger, which shows the direction of current, which is going from left to right. My magnetic field is going from north to south. So basically it's going, it's going into the page. You can see that it's facing towards the page. So what is the direction of the force on the conductor? So the conductor will be moving upwards. The force on the conductor will be in the upward direction. Got it, people? Is it clear? Able to understand this? Able to understand this? I mean, I don't think it's that complicated, but I know that some of you guys might find this a little difficult to imagine at first, but I hope you guys are getting the basic idea behind it, right? So it's as simple as that. You just need to understand this one simple funda that it's nothing. Again, just remember this acronym: father, mother, child. Father, mother, child. So father is nothing but the force on the conductor. Your mother is nothing but the direction of the magnetic field, and child is nothing but the direction of the current, whatever is the direction of the current. So direction of current is basically shown by this middle finger, which is basically going from left to right. The magnetic field is going from north to south, so it's basically going in this direction. So what will be the force in the conductor? In the upward direction. So the conductor would be moving upwards. It will be pushed upwards because of the the Lorentz force acting on it. Simple as that, right, guys? So this is your Fleming's left hand rule. To give you another example, this is one more example we can take. So you see this, the direction of current is basically this is the direction of current. So just pay attention, positive to negative terminal. You can see that current is flowing in this direction. So inside the conductor, current is flowing in this direction. So basically it's going from, you can see that it's going from left to right again. So middle finger shows the direction of current. Magnetic field is going from north to south. So basically it's going upwards, right? It's going upwards, which is shown by my, okay, I'll just show that to you because I'm just doing it to myself all this while. So current is shown by my middle finger, which is basically going from left to right. Magnetic field is upwards. It's going upwards. So what is the direction of the conductor then? Upwards. It's coming outwards. It's coming towards you. So that is why if you look at the GIF also, you can see that the conductor is actually going away from the magnet. All right. So once again, people, pay attention. The middle finger shows the direction of the current. So here the current is going from left to right. The index finger shows the direction of the magnetic field, which is going upwards, because magnetic field, or when you talk about the magnetic field, it's always going from north to south. Finally, what will be the direction of the force on the conductor? Force on the current carrying conductor would be outwards. Simple. That is why you see that the conductor is moving away from the magnet. Got it? Yeah, I can remember it as FBI also, but FBI can be used for Fleming's right-hand rule as well. So because you can talk about induced current over there. So I use FBI for induced current, that is Fleming's right-hand rule, and father, mother, child for Fleming's left-hand rule. So how you are, see, if you're finding FBI more easier, then please go with that, because it's basically the same thing. There's nothing there's nothing too different about it. It's basically the same thing, just that for FBI I use it for induced current. So using your Fleming's right hand rule, you can find out the direction of the induced current. For that I use FBI, and father, mother, child, I use it for your Fleming's left hand rule. But again, it is totally up to your comfort. All right, it's totally up to your comfort. And yes guys, there's no numericals as such, so it's just theory. So if you understand the theory, that itself is more than enough, and you can easily get through this chapter. Right, anyways, now talking about the direction of the force on the current carrying conductor, guys, there are two factors that it depends on. One is the direction of the magnetic field. For example, initially I had kept the magnet, this is the north pole, this is south pole, and you saw that the conductor was going away from the magnet. If I reverse the polarity, so if I change the polarity as north and south, then the force on the conductor will also change. So that means this conductor will move towards the magnet at that time. All right, so it depends on the direction of the magnetic field. It also depends on the direction of the current as well. So initially, if you look at this example, current is flowing from left to right. But if I change the direction of current, so if over here you can see that the current is going from left to right. If in case I change the direction, if I change the polarity of the battery, if I make this as the negative terminal and this is the positive terminal, that can also have an impact on the direction of the current carrying conductor. So you can see over here, guys, here if you pay attention, this is the south pole, this is the north pole. When I change the polarity, this is the north pole now, this is the south pole. Can you see this? Your conductor is going towards the magnet. So the direction of the magnetic field and the direction of current, both of these are also very important factors on which the direction of force on that conductor depends on. Very important to remember that, because you have to use your Fleming's left hand rule, right? So if, for example, over here, if I have to show you this, current is exactly same. Current is going from left to right itself. So middle finger shows the direction of current. It's going from left to right itself. But magnetic field is going downwards this time. The magnetic field is going from north to south. So if you look at the direction of the force of the current carrying conductor, okay, I showed the other way around. The middle finger shows the direction of current, which is going from left to right, and magnetic field is going from south to north, right? It's going from north to south. So basically it's going downwards. So the force on the current carrying conductor will be towards the magnet, and that's why it's going towards the magnet. Got it? So that's it, people. That is the direction on which the force of the current carrying conductor depends on. Finally, the last thing I'm going to talk about is the factors on which the magnitude of force depends on. How much the value of force, that is something which depends on several factors. One of the major factor that it depends on is basically the current. More the current, more would be the force on the current carrying conductor. So basically F is directly proportional to I. So the magnetic force on the current carrying conductor would increase if you increase the current as well. So that is one factor it depends on. The force on the current carrying conductor is directly proportional to the current. More current is flowing through the conductor, more would be the force on that current carrying conductor. Second thing it depends on is the magnetic field of the magnet, the permanent magnet. So initially, let's say that I use a weak magnet. So the amount of force acting on it will not be that much. But if I replace that with a much more stronger magnet, with a stronger magnetic force, then the force on the conductor would also increase. In other words, F is directly proportional to B. B is nothing but the strength of the magnetic field. I'm talking about the external permanent magnet, all right? The permanent magnet. So if I replace that magnet with a stronger one, that is also something that can, mess around with the force on that, the amount of force, the magnitude of force acting on that current carrying conductor. Finally, the length of the conductor is also an important factor. More the length, more would be the magnetic force acting on it, because basically, because of the charges, there are more number of charges flowing. So because of that, as the length of the conductor increases, the force on the current carrying conductor would also increase. So basically what we just saw right now, people, F is directly proportional to I, F is directly proportional to B, and F is directly proportional to L, that is the length of the conductor. So I can write it as F is proportional to BIL, right? I can just write it as BIL because it's easier to remember. Bill, F is directly proportional to BIL. Now, what I'm going to do is I'll remove this proportionality sign by introducing a constant called as K. So the formula that becomes F is equal to KBIL. But here's the thing, guys, the value for K is 1. The value for K is 1 if I take all of these as the SI units. So the formula then becomes F is equal to BIL. This is the formula to calculate the force on a current carrying conductor. All right, so F is equal to BIL is again, you won't have numericals based on it, but it is something that you need to know as a theory part of it. You must definitely know about it. So F is equal to BIL is the formula which is used to calculate the magnitude of Lorentz force. How much Lorentz force is acting on it, that can be calculated by understanding the magnetic field, the strength of the magnetic field, the length of the conductor, and the amount of current flowing through that conductor. All right, people, is it clear? All good, people? So this is the topic. That is all the topic for today. We are done with the learning part of it, but yeah, we have a lot of questions to go through, but I hope you understood everything, people. Is there anyone who did not understand any part of it, anything that you're confused about? I'm pretty sure it's clear because it's very straightforward, but if there is any confusions, let me know so that I can clear it up. All right, so this is a basic formula. You won't have numericals based on it, but you still need to remember this formula because they might ask you as a theory question. All right, there'll be no numericals, but you'll still have to remember it. F is equal to BIL. You will be doing numericals later on. All right, in your higher grades, you'll be doing it 11th and 12th. Right now, you won't have numericals, but you still need to remember this formula. All right, guys, let's go on to the let's go on to the quiz questions right now. But once again, before that, I have a very important and very awesome and exciting news to share. I don't know if you guys, if you guys have been a part of Vedantu family, you would know that last year we conducted something called as Vedantu's Got Talent, where students from all over the country could come in and showcase their talent. Whether you're good at singing, dancing, drawing, whatever it might be, you could showcase your talent and we could be getting some exciting prizes also. So we are back again. Season 2 of Vedantu's Got Talent is back now. So if you want to submit your entries, the link is given in the description. You can check that out. If you're into dancing, singing, arts and craft, fancy dress, storytelling, whatever you're good at, you can basically take part in that. That is for pre-KG to third standard, and for 4th to 12th standard you have dancing, innovative ideas. If you think that there is something that can change the world or impact the world, you can put that also up. Singing, open mic challenge as well, and comedy nights with couple and all that. If you're good at that, if you're good at roasting people, you can do that also. Musical instruments, if you're good at guitars and pianos and all that, and arts and crafts as well. So you have lots of opportunity. Whatever you feel like you're good at, you can take part in that. And there's no hard bend rule that you can only participate in one category. If you're more good at more than one or more, you can participate in that as well. So all you have to do is this: you have to record a video of your performance, whatever it is. If it's open mic or dance or singing, you just need to record yourself and send the YouTube link through a Google form. The Google form would be put up on the channel later on, so you keep an eye out for that. So make sure you subscribe so that you get the notification. So whenever the Google form is up, you guys can enter your details and stuff. And it should not be more than 3 minutes, so it's going to be a very small video, but it's an opportunity to expand your own your own horizon. You can actually test your limits, something that I'm looking forward for, because last year it was a fantastic celebration. So hopefully this year also is going to be the same. So do not this is your age to to explore things. So give your best, see if it works out for you or not, and see if you're good at it, because you never know, you might surprise yourself. You might not know that you're good at it, but turns out you're good at it. So try it out. There's no humiliation in it. And yeah, the first prize is going to be a laptop, people. You're going to get a full-fledged laptop and you will also be getting free Vedantu subscription. All the classes for free, all the features, everything for free of cost. For the second price, you're going to be getting a smart tablet and Vedantu subscription as well. Third prize would be getting a headphone and Vedantu subscription, and the fourth to 10th prize would be getting Vedantu merchandise, that is mugs and bags and pens and whatnot. But yeah, the thing is that, guys, it's not every category has a winner. It's not that there's only one winner. Every category has a winner. You'll have winners for dancing. Also there'll be a winner for singing. Also there'll be a winner for every category. You'll have winners, right? Every category. So it's a good opportunity. I mean, why wouldn't you want why would you want a free laptop, people? Yes, this is VGT, Simran. This is VGT. This is VGT that we're talking about, right? Vedantu's got talent, so why not? I mean, yeah, this is an amazing opportunity for you guys to showcase your talent. I'm really excited to see how it's going to be like, because last year it was super amazing. Hopefully this year also it's going to be fantastic. I'm pretty sure it's going to be fantastic because the crowd is much more bigger this time. So hope to see you there, right? So you just have to look for the Google form. I'll be putting it up in the description, and you'll also be getting it up later on. We'll be putting it up as stories, so you can send your entries over there. Need to record a 3-minute video and send it. See for yourself. All right. Anyways, so people, that is basically, so it has already started. So 14th of January was when it started. So it's going to go on for some time now. So submit your entries and see where it takes you. Right? All right, people. So let's go on to the quiz questions now. But before that, one more important announcement that I want to make is this. Not announcement, but something that can help you. Small bit of motivation to help you in this path that you guys are on right now. Because I know that sometimes we all have this feeling that you're alone. Sometimes you have this feeling that, you're not going in the right direction. Or sometimes you have this feeling that, I'm not doing enough. So let me tell you one thing, people. There's no shame in asking for help, right? There's no shame in asking for help, because if you know that you need to get that help that is going to push you to become better, then why wouldn't you take it up, right? Because we all want to prove that we are better than others. That's always there, right? That ego that we have, that we are better than the other person. Why would I want his help, or his or her help, is something that we always have at the back of our head. But sometimes in life, we just need to let go of that ego and ask ourselves that, can I do better if someone is there by my side to guide me in the right direction? And if the answer is yes, then do not hesitate another second and take that person's help. Whatever it is, whoever it is from, doesn't matter if it's your dad, mom, if it's your brother, if it's your neighbor, as long as they are ready to spend their time with you. So why wouldn't you give them a chance to help yourself out for your own future, right? So I would just say that if you're someone who is hesitant of taking or accepting help, please forget about that, because right now it's your need more than anything else, right? It is your need to complete the syllabus. It is your need to understand the concepts. So forget about that ego and all. Focus on your path, and your goal, it should be to score good marks in your final examinations. And for that, whatever means is necessary, take it up and make it happen, right? Shine brighter than a star, right? Now, if everything else fails, and if there's no one of that sort to help you or guide you, then Vedantu is always here for you, people. Vedantu's courses are here, and it is always there to guide you guys in the right direction, to help you, to nudge you in the right direction, to give you that support system that you need to push yourself forward. Because again, we have a lot of students who are falling in the same category as you. You might feel like you're alone, but again, we have students from all over the country. So you'll know that you're not alone, and there are a lot of people around you who are facing the same problems. So your problems won't feel like it is that big. And more importantly, it'll give you that support that you need to push yourself forward. So this is what you're going to get at Vedantu. Let me just quickly rush through it, and then we'll come back to the quiz. Don't leave yet, because we have the quizzes right after this. So first thing, people, you can always watch the recordings of any sessions at any point in time you want. There's no time restrictions. In the middle of the night, you feel like you did not understand a concept, open the recordings, go through it whenever you want, right? Just like YouTube. And we always make sure to have a lot of fun while taking the session. It's not a boring one-way conversation or a one-way transaction. We always tend to have fun. You can ask any of my regular students, they would vouch for that I try my best to keep the class as interesting and as light as possible, so that You enjoy the process of learning. It should not be a learning should not be a boring process. It should not be like how we did it, right? So for that reason, we always try to change the way we approach the concepts, and we always try to add in a little element of fun as well. So we generally start off with a riddle or something of that sort to keep you guys engaged. And not only that, we will have thumbs up, thumbs down to keep you guys engaged in the session, hotspots, quizzes. Again, all of this is to keep you engaged throughout the session, so that your concentration does not get deviated, and more importantly, you're constantly pushing yourself to become better. That's what we aim to do. You'll have fastest fingers list to motivate yourself. You have stars and percentage and whatnot to see how well you have performed in the class. For every right answer you get a star as well. You have drum rolls, rockets and doles and balloons and whatnot. Tons and tons of activities are going on all the time. We have leaderboards, again, to see how well you've performed in comparison to the class. And not only that, you can even get your doubts solved inside the class itself, because every session would have class teachers and the master teacher you have an opportunity to talk to the master teacher, because in YouTube that is not an option, right? You can't talk to the teacher. It's a one-way conversation. You just listen and you type it out. But here you can actually talk to the teacher one-on-one and get your doubts cleared. You can even the teacher can even highlight the questions that he or she feels like is important. And you also have the class teachers throughout the session, so you can get your doubts cleared at any point in time you want. Just to give you an idea, this is like this is one of the sessions that happened yesterday, I believe, right? So in this particular session, just to give you an idea, this is a very small crowd. About 61 doubts were asked in the class, and about all that 61 doubts were cleared inside the session itself. So you can see that you're getting a constant support to help you, to nudge you in the right direction, to make sure that you're not getting deviated, and you're not lagging behind anything, right? You can even download the notes, every handwritten note, everything can be downloaded, and you can refer to it whenever you want. And not only that, you also have stress relief sessions and entrepreneurship classes. You have coding classes. Lots of other activities are also going on parallelly, right? And if you guys want to enroll into these courses, if you want to experience this, you can basically go to the link that is given in the description below. So this is the video. Oh, again. Ice cream cake. All right, so anyways, so what do you do, people? For a second there, my mouth was watering. Anyways, what you have to do is, guys, go to CBSE Term 2 full syllabus and click on this particular link. This link is all you need to for all the 10th standard students, that is. For ICSE, it's going to be a little different. It's going to be ICSE crash course, which is going to be the link right below that. So here you can see for yourself, the entire course would be done. All of the syllabus would be completed here for all the 6 subjects: physics, chemistry, bio, math, English, social science. Every single subject would be covered, and full revision would be there. And you also can you'll also be getting English grammar classes also over here. Full term syllabus, full term to syllabus would be getting over here. And all of this, people, all of this, that is until the end of the year, that is until the end of your term 2 examination, you're getting it for just 5,400 rupees. 5,400 rupees for the next 4 to 5 months. That is until the end of your examinations. These classes will be going on, and it's just 5,400 rupees, which is a very, very, very nominal price. Even if you take it as 1,000 per month for all 6 subjects, 1,000 per month is, I think, is an amazing deal. I mean, I remember when I used to go to college, when I used to go to school, my tuition fee for math and all used to be like 500 per subject. 500 per subject. Right now you're getting all of the 6 subjects for about 1,000, 1,200 per month. That is an amazing deal, and you're just getting it for 5,400 all in all. And if you're not confident, you're attending for the first time and you're not confident about it, you can try the 1-month program. Then don't have to, 5,000 is still a very big amount. So if you don't want to go for that, you can go with the 1-month program, which is 1,170 rupees. It might say 15 days, but if you use my coupon code AME Pro, right? If you click on that link, the coupon code is already applied. That will give you a 30-day program. So it's not going to be 15 days, it's going to be for 30 days. For 30 days, you're going to be getting it for 1,170 rupees, which is again a very good deal. So you can check that out for the next 30 days. Again, all of the things that I just talked about, you can experience it. And then later, if you want to continue, you can continue with that. Right, guys? So that is what you get out of Vedantu. And if you guys want the extra help of the mobile app also, that is outside the class, you want to get your doubts cleared, you can enroll into Vedantu Classic. That's about 7,200. So that's about almost 2,000 rupees more than the light program. But again, here you get extra help. That is, you also get the doubts app as well. So that is an extra thing, extra added feature that you're getting out of it. It's not just you're paying for no reason. It's just you're paying extra for that, right? And 1 month program for that is 1,530 rupees. Right. So anyways, guys, I would say that go ahead with the 15-day trial at least. See for yourself. It's 15-day will become 30 days. So see for yourself. Anyways, you're getting that 30 days. You'll be getting the best, best support that you can possibly imagine, and you can experience it. And then if you want to continue, you can continue after that. Right. So anyways, guys, let's get into the quiz questions right now. So here's what you have to do, people. Whoever is joining in right now, please go to joinmyquiz.com and enter the code 554793. All right, once you guys are in, let me know. Let's go. Hi, Insider, what's up, buddy? Yo, I'll see you at 6:15. All right, quickly, guys, quickly. Who is in right now? I want all of you guys to join the quiz as well. So the code is 554793. You have to go to joinmyquiz/pro and enter this code 554793. All right, let's go. Come on. All right. Hi, Tanmay, what's up? All right, people, I'm hoping that everyone's here. I'm going to start the quiz now. So moving on to the fourth question in total, which is the first question from the topic that we just did today, right? So here is your first question from the topic. The force on a current carrying conductor when placed perpendicular in a uniform magnetic field is F is equal to BIL, F is equal to B by IL, F is equal to L by BL or BI, or is F is equal to I by BL? Very simple question. I believe that you should, you should get the answer without even thinking twice, because it's a very straightforward question. Let's see how many of you guys can figure it out. Anyways, 3 more seconds. So I believe that a lot of you guys left the quiz. So people, quickly join the quiz again. Join the quiz. I really don't know if you guys are in or not. So please join the quiz again. The code is 554793. All right, you have to go to joinmyquiz/pro and enter the code 554793. All right, once you guys are in, let me know so we can continue with the quiz, because there are very few guys over here in the quiz. I want everyone to join the quiz. All right, quickly. Once you guys are in, let me know in the chat box so that we can continue with the session. All right, so that I can go to the next quiz question, because there's no point in having quiz with 4 or 10 people. Quickly. It'll be fun with more people around. So quickly join the quiz, guys, because I know that you guys want quizzes. So I'm pretty sure none of you guys are here who are like, sir, no, sir, I is not want quizzes. I is good boy. I'm pretty sure nobody's like that. So quickly join the quiz, people. All right, I'm going to move on to the next question then. The fifth question for today. Also the second question right after the topic. So here is your fifth question. The question is, a magnetic field exerts no force on an electric charge moving perpendicular to its direction, magnetized iron bar, a stationary electric charge, or a magnet. A magnetic field exerts no force on which of these? A electric charge moving perpendicular to its direction, a magnetized iron bar, a stationary electric charge, or a magnet. Very simple question, guys. Very simple question. I'm pretty sure some of you guys would have given the right answer, but some of you guys would have been a little confused about this. However, the answer is going to be option number C, people. It says that if the charge is stationary, that means there is no current flowing through the conductor. If there is no current flowing through the conductor, then there will be no force on that conductor, because in order for Lorentz force to act, the charge has to be moving. It has to be in motion. If it is stationary, if there's no current flowing through the conductor, then that conductor will not experience any force at all. So hence, option number C is definitely the right answer for this question. All right, moving on to the sixth question, people. The sixth question. Whoever's joining in right now, please join the quiz as well, guys. The code is 554793. Joinmyquiz.com. All right, so quickly join the quiz as well. On which of the following does the magnitude of Lorentz force depend? The magnitude, the value of Lorentz force depends on which of these? Options are the strength of the magnetic field, electric current, the length of the conductor, or all of the above. On what factor does the magnitude of Lorentz force depend on? Very simple question again. I'm pretty sure you would have all given me the right answer for this. I'm hoping, fingers crossed, touch wood. Let's see. Here we go. Here is your leaderboards. We have at this point in time, we have KV, Devadarshini, AKR sir, Zain, all is well, Minnal Murli, Jayani. Then we have, who else? Jayani, then it's Doraemon. Alright, big fan. Ayushi, Dr. Shriya Singh, what's up, Dr. G? Soham, Dipanshu, Rudransh, big fan, thanks a lot. Narendran, Shanmuga, followed by Jay, Harsh, Harshit, Samosa, Yabu, and Shresht, Alvin. It goes on and on and on. Super awesome, guys. 15 of you guys got the right answer. That is fabulous. That is fabulous. Going on to the 7th question, the second last question for today. Here we go. Which law can help us find the direction of force on a current carrying conductor in a magnetic field? Again, a jujube question. Is it the right hand thumb rule? Is it the left hand thumb rule? Is it Fleming's left hand rule? Or is it Fleming's right hand rule? Which of these can help you to find out the direction of the force on a current carrying conductor placed in a magnetic field? Hi Harika, what's up? Good afternoon, good evening, what's up? Sasriya Kal. Guys, if you're just joining in right now, please join the quiz. The code is... what's the code? The code is 554793. All right, go to join my quiz/pro and enter the code 554793 to enter the quiz, to take part in the quiz. All right, we have last 2 questions left. It would be good if you guys can take part in the quiz as well. Come on, quickly. All right, done. Time's up, people. Here we go. The leaderboards once again. Still KV though. KV is on full on Chawanprash Josh. KV has taken like 10-15 spoons of Chawanprash today. KV followed by AKR, Zain, Devadarshini, Minnal Murli, all is well, Jerry, Doraemon, Ayushi and Rudransh. Congratulations. 12 of you guys got the right answer. Some of you guys like left in thumb rule. When did we come up with left in thumb rule, people? Right in thumb rule, okay. Somehow all right, it's a what to say? There's a small confusion. What is this left in thumb rule? What is this? Huh? Thumbs up, taste the thunder or what? That's why stop watching too much TV and all. This is what happens when you watch a lot of TV and you see stars jumping from buildings and all just to buy a thumbs up. This is what happens. All right. Moral of the story is that. So stop. You guys are in 10th standard now. Enough. All right. Last question. Magnetic lines of force inside current carrying solenoid are ellipse. Is it perpendicular to each other inside the solenoid, parallel inside the solenoid and circular at its end, or circular? Magnetic field lines, magnetic lines of force inside the current carrying solenoid are ellipse. Is it perpendicular to each other inside the solenoid, parallel inside the solenoid and circular at the ends, or circular? This is actually a concept from the previous session. Unfortunately, I think there was a misplacement over here, but still, it's still a good question. So you guys can tell me what the answer is. All right. Okay, 9 more seconds, people. 9 more seconds, and we are almost done. I want that Josh, that sound. It sounds like Kaun Banega Crorepati. Anyways, time's up. Here we go. This is your final leaderboard, people. So this is gonna be it. The last and the final question. Unfortunately, अरे KV, I think I put मैंने आंख डाल दिया KV पे. आंख डाल दिया. That's why, because that poor guy was doing so well until the end. He was in the last question because of what I said, I believe. Sorry KV, sorry, what to do. But anyways, it's gonna be parallel inside the inside the, so it's more or less like a bar magnet. So inside the solenoid it's gonna be parallel. Outside the solenoid it's gonna be circular in nature. Anyways, so here is your final leaderboards. The top scorers for today, we have Zen, followed by KV, and then Deva. Congratulations, guys. Congratulations. Well done, Devadarshini. 4th is Minnal Murli. 5th is House AKR. Then we have All is Well, Jani, Doraemon, Ayushi, Rudransh, Dr. Shriya Singh. Congratulations. It goes on and on and on. Fabulous job, people. Fabulous job. I'm proud of you guys, but still, I mean, I'm still like, why KV? Why? Huh? Why did you do this? Why? Until the last minute, everything was going so well for you. Last minute, you went and you went and threw it all off. Anyways, so people, that's all for today. If you have any doubts, anything that you would like to ask me, you can get it cleared right now. Otherwise, you may leave. Thank you for joining. Thank you for spending your time with me. Do not forget to like, share, subscribe. Yeah, like every other YouTuber. Subscribe to the channel, because people, why would you want to miss out on these amazing content? We'll be coming out with lots of amazing stuff to help you with your term 2 examinations. So why not? right? What are you going to lose anyways, right? And on top of that, like the video if you enjoy the session. So that's it, people. That's all for today. I'm not able to see any of your chats for some reason. I don't know, there's a lot of delay today. Not able to see any of your chats and all. But anyways, that's it, people. That's it for today. Thank you for joining. Catch you guys in the next session. Take care of yourselves. Stay safe. Is it Kirti? Good luck. That's all. It's all. It happens. But you did well. You did really well. But just the last one. So what will happen if the magnetic field gets reversed? If the magnetic field gets reversed, then the force in the conductor will also get reversed. So the direction on the force in the conductor depends on magnetic field and the direction of current. So if you reverse the magnetic field, that can also impact the force in the conductor. If you reverse the direction of current, that can also impact the direction of current, the direction of the force in the conductor. All right. Hi Zen, shout out, hey Zanji, congrats. Well done. Super awesome. Until like silent killer you are. You're like Randy Orton. Like silent RKO you put towards the end. Until the end it was all chill. Last minute RKO. That's all. Sure, often we will discuss the sample papers also. We'll have a separate video for that for sure. All right, that's actually something that we are planning. We'll be coming out with that next week. Mostly sometime next week we'll be coming out with that. There are a few corrections that has to be made. So once it's done, we'll be coming out with that. All right. Kirti, electricity one shot is yet to be recorded. I have not recorded it yet. That's why. It's not done recording yet. I have been having a lot of throat issues lately, so because of that, no, I haven't been able to record it. Record a lot of videos. I've been pending. There's a lot of pending work because of my throat. So once I'm fine, once I feel like my throat is back, then I can record all of that. I'm just waiting for that. Right. So nonetheless, guys, thank you for joining today. Have a wonderful evening. Take care whenever you're watching it. Have a wonderful morning, wonderful evening, wonderful good night. I'll catch you guys in the next session. Sweet dreams. Take care. Stay safe and adios. Arigato. Bye bye. Take care.